There are ships, and then there are floating cities. Imagine a vessel so enormous that it carries dozens of fighter jets, thousands of people, and enough technology to operate like a military base. In the middle of the ocean, it doesn't need a runway, it doesn't need a nearby airport, it simply moves across the world's oceans while launching aircraft. Again and again, this is the aircraft carrier, one of the most complex machines ever built by humanity, but its true power isn't its enormous size, it's what happens. On its deck, fighter jets can launch from a run far shorter than anything you would find on land. They accelerate from zero to incredible speed. In just a few seconds, then, they disappear into the sky, and when the mission is complete, they return to the same moving ship, trying to land on a narrow strip, surrounded by ocean. Behind this incredible operation are nuclear reactors, massive engines, advanced radar, weapons systems, elevators, catapults, and thousands of people working together with almost no room for mistakes. So how does this enormous floating machine actually work, and what makes an aircraft carrier one of the most powerful weapons on Earth? Tonight, we're going inside the world's most advanced aircraft carriers. An aircraft carrier looks enormous from the outside, but its true scale becomes difficult to understand until you step inside. Below the flight deck are multiple levels filled with machinery, storage areas, workshops, medical facilities, control rooms, and living quarters. Thousands of sailors can spend months living on the same ship. They sleep, eat, work, and train without ever seeing land. The carrier must provide almost everything its crew needs: food, fresh water, electricity, fuel, medical care, and constant communication. Deep inside the ship, powerful engines generate the energy needed to move this enormous structure through the ocean. On some of the world's most advanced carriers, nuclear reactors provide that power. They can operate for years without needing conventional fuel for propulsion. But the most impressive part is still above them: the flight deck, a massive moving runway where fighter jets take off and land at sea. And unlike an airport, this runway is constantly moving. The ocean is never still, wind is constantly changing, and every aircraft has only seconds to get everything right, because on an aircraft carrier, there is almost no room for a second attempt. A fighter jet doesn't have a long runway. When it is sitting on an aircraft carrier, the available space is extremely limited, yet somehow a multi-ton aircraft must become airborne in only a few seconds. This is where one of the carrier's most impressive systems comes into action. The aircraft is positioned on the launch area. The pilot, every system, the deck crew move into position. Everything must be synchronized. Then the engines reach maximum power. The aircraft begins accelerating, but it still needs an enormous additional force to reach the required speed. On modern carriers, a launch system helps propel the aircraft forward. In some systems, a powerful electromagnetic catapult accelerates the aircraft along the deck. Within seconds, the fighter reaches takeoff speed, and suddenly it leaves the ship and enters the sky. The entire process can happen in less than a minute, but launching a fighter is only half the challenge, because eventually the aircraft must come back, and landing can be even more dangerous. Launching a fighter is impressive, but bringing it back may be even more difficult. Imagine trying to land a high-speed aircraft on a narrow runway that is constantly moving. Now add strong winds, ocean waves, and darkness. This is the reality of carrier aviation. As the fighter approaches, the pilot must line up perfectly with the deck. But there is another problem: the ship is moving, the aircraft is moving, and the landing area is constantly changing position. At the final moment, the pilot aims for a series of arresting cables across the deck. A small hook attached to the aircraft must catch one of them. If it succeeds, the aircraft can be stopped within seconds. If it misses, the pilot may have only one option: take off again. Then try another approach. Every landing requires extraordinary precision, and behind the pilot, an entire team is watching. Deck crews, air traffic controllers, engineers, and other specialists all work together to make the landing possible, because one mistake can damage an aircraft or put lives at risk. And this is only one small part of the carrier's enormous operation, because while aircraft are taking off and landing, the ship itself is running an entire military base. Above the water, the aircraft carrier looks like a giant runway, but underneath is an entirely different world deep inside the ship. Thousands of machines work continuously: power systems, fuel systems, radar equipment, weapons storage, aircraft elevators, cooling systems, and enormous engines all operate together. One of the most impressive systems is the aircraft elevator. These massive platforms move fighter jets between the hangar deck and the flight deck. An aircraft weighing several tons can be transporting vertically in only a few moments below the deck. Maintenance teams work around the clock. Every aircraft must be inspected, refueled, repaired, and prepared for its next mission. A carrier cannot simply return to an airport for maintenance. Everything must happen on the ship. That means engineers must be prepared for almost any problem at the same time. The carrier's radar systems constantly scan the surrounding airspace. Sensors search for aircraft, ships, and potential threats. Information is collected and sent to command centers inside the ship. Their specialists build a constantly changing picture of everything around them. The result is something far more complex than a giant ship. It is a mobile military ecosystem, and keeping that ecosystem running requires thousands of people. An aircraft carrier cannot operate with technology alone. Behind every aircraft, every radar screen, and every engine are thousands of people: pilots, engineers, mechanics, doctors, sailors, air traffic controllers, security teams, and countless specialists. All have one responsibility: keep the carrier operating for months. Many of them may remain far from land. Their entire lives take place on the ship. They eat, sleep, train, and work in a constantly moving environment. Some teams begin working before sunrise, others continue through the night, because the flight deck never truly becomes quiet. When a fighter launches, dozens of people may be involved. When one returns, another team is already preparing for the next mission. Every movement is carefully coordinated. A single mistake can create a chain reaction. That is why training is relentless. Emergency drills are repeated again and again. Fire crews practice fighting fires. Medical teams prepare for injuries. Engineers train to repair critical systems, and sailors practice responding to emergencies at sea. Because an aircraft carrier cannot simply stop and call for help. It must keep moving. It must keep operating. And when necessary, it must defend itself. That brings us to the carrier's most important role: power projection. An aircraft carrier is more than a ship. It is a mobile military base that can travel almost anywhere on Earth. It can carry fighter aircraft, thousands of personnel, radar systems, weapons, fuel, and enormous amounts of equipment. It doesn't need a foreign airport. It doesn't need a permanent base nearby. It can arrive off the coast and begin operating from the ocean. That is what makes aircraft carriers so strategically important. But their greatest strength is not the ship itself, it is the aircraft operating from its deck. Fighters can travel hundreds of kilometers away from the carrier, complete their mission, and return to the same moving runway at the same time. The carrier's radar systems monitor the surrounding area. Other ships can operate alongside it. Submarines can protect it beneath the surface. Aircraft can protect the skies above. Together, these systems form a massive naval force. But building something this enormous comes with a staggering price. Modern aircraft carriers can cost billions of dollars, and operating them can cost billions more. Yet nations continue investing because few machines can provide the same combination of mobility, aircraft technology, and global reach. The aircraft carrier has become one of humanity's greatest floating engineering achievements, and its future may be even more impressive. The aircraft carrier has already transformed naval warfare, but its evolution is far from over. Future carriers may rely on even more automation. Artificial intelligence could help manage thousands of systems simultaneously. Unmanned aircraft could operate alongside traditional fighter jets. Advanced sensors could detect threats far beyond the horizon, and electromagnetic launch systems could make aircraft operations more efficient than ever. But the basic idea will remain the same: a massive floating platform carrying an entire ecosystem of aircraft, people, machines, and technology across the world's oceans. That is what makes an aircraft carrier so extraordinary. It isn't simply a giant ship. It is a moving city, a military base, an airport, a power plant, and an engineering masterpiece. All at the same time, thousands of people keep it alive, hundreds of systems keep it moving. And dozens of aircraft can turn its deck into one of the busiest runways on the planet. From the first steel plate to the moment a fighter launches into the sky, every part of the carrier represents decades of engineering and innovation. And perhaps the most remarkable thing is that this entire machine can move across the ocean without ever needing a runway on land. If you enjoyed this documentary, don't forget to leave a like, subscribe to RailForge for more documentaries about military technology, space, engineering, science, and the machines shaping our future. Thanks for watching, and we'll see you in the next documentary.